Hi, this is Mrs. Jackson. This is part 3 of the 4th section of chapter 4 on the unit circle. And in this section, we're going to look specifically at the 45, 45, 90 special right triangle. And that means all the multiples of a 45-degree angle on the unit circle. Okay, so let's zoom in here. And this time, instead of being divided into 6, we're dividing into fourths on each side of the circle. And so if I just write my degrees first, I have 0 degrees here, 45, 90, 135, 180, 225, 270, and 315. And then all the way back around, bringing us to 360, which is the same as the 0 point. Now let's break this up into fourths. So we've got 0 pi radians. We have 1 pi over 4 radians. We have 2 pi over 4 radians. 3 pi over 4 radians. 4 pi over 4 radians. 5 pi over 4 radians, 6 pi over 4 radians, 7 pi over 4 radians, and finally all the way around is 8 pi over 4 radians. Just like we did with the 30, 60, 90 angles, we're going to simplify these if we can. So of course this is 0 pi radians. Pi over 4 radians can't be simplified. 90 degrees is pi over 2. 3 pi over 4 cannot be simplified. 4 pi over 4 is just pi. 5 pi over 4 stays the same. 6 pi over 4 simplifies to 3 pi over 2. 7 pi over 4. And finally, 360 is the same thing as 2 pi. And I'm just going to clean up my unit circle by getting rid of the unsimplified ones. Now let's just look again at the 45, 45, 90 special right triangle. And of course this is an isosceles right triangle, so both legs are congruent. So if we call both those values x and we use the Pythagorean theorem, we will see that the hypotenuse is the square root of 2 times the sides. Now the definition of the unit circle is that hypotenuse is equal to 1. So if this is 1, we can see that the sides, actually I'll write out a little formula here, the hypotenuse equals the sides, I'll just say x times square root of 2, 1 equals x times square root of 2, so x equals 1 over the square root of 2, which is equivalent if we multiply the numerator and the denominator by square root of 2, we're going to get square root, let me do that in red, square root of 2 over 2. So both these sides in the unit circle are going to be square root of 2 over 2. I'll just label them here. So if we go up to that unit circle, we're going to just adjust the signs for whatever quadrant that we end up being in. So the first angle, 0 degrees or 360 degrees, the location of that point is going to be 1, 0. And at pi over 4 radians, we're at square root of 2, square root of 2 over 2. Up here at the 90, we're at 0 for the x value, positive 1 for the y. And over here, we're just going to have the same values, but we have to adjust the signs. The x value is negative in quadrant 2, the y value stays positive, and at pi radians we're at negative 1, 0. Everything is negative in quadrant 3, so both these sides are going to be negative. And I don't have enough room here. Down at 270 degrees we're at 0 for the x and negative 1 for the y. And over in quadrant 4, only the y value is negative. So again, just like the 30, 60, 90, Every point on that unit circle has an x and a y, and that is the cosine of the angle for the x value and the sine of the angle for the y value. Okay, so let's do a few examples like we did with the 30, 60, 90. So for example, if I said find the cosine of, say, 1,305 degrees, obviously that's not on the unit circle, so it would start to go around in a counterclockwise fashion. So we go around once, it's 360. Around twice is 720. 1305 minus 720 gives us 585. We can keep going. Around a third time is 225. So this would be the same thing as cosine of 225. Cosine is the x value, and we look at the 225 angle, and the x value is a negative square root of 2 over 2. Example 2, let's try a negative angle. So sometimes we're given negative angles. Let's say, what's the sine of negative 270 degrees? If we are going around the circle with a negative angle, that means we're going clockwise. So instead of starting here at the positive x-axis and going counter, we're actually going to go in this direction. So negative 270 degrees is the same thing as positive 90 degrees. And sine is the y value. And so the sine of negative 270 or the sine of 90 is going to be 1. And let's try some radians. So say I said find the cosine of 13 pi over 4 radians. So 13 pi over 4 is not on the unit circle, so you're going to have to find its reference angle. So the easiest thing, in my mind, the easiest thing to do is rewrite this as a mixed fraction. So 4 goes into 13 3 times with a remainder of 1/4. So if we look up at the unit circle, this is the same thing as 3 and 1/4 pi. So if we kind of look up here, we go in our standard position. We go around once in the circle. That's 2 pi. 3 pi is here at 180. And now we're going to go around a quarter more because that's the only thing we have left. So right here is the same angle. So 5 pi over 4 radians is the same thing as 13 pi over 4 radians. By the way, same thing as 225 degrees. So we're going to be negative either way, whether we're looking at sine or cosine. And so both of these are negative square root of 2 over 2. And finally, let's do like a little basic equation. If I said the cosine of theta equals negative square root of 2 over 2, what is theta? Well, I would have to bound that in some way because there's an infinite solution set to this. But if I said, typically you'll see a problem saying what is theta between 0 and 360 degrees. So if I said that, then theta would be in quadrant 2 and 3. That's where our x values are negative. So we would say theta is 135 degrees and theta is 225 degrees. And if I asked you for radians, you could put that in radians. All right, so that is the 45/45. And let's take a look at putting it all together now. All right, so all together, this is what you would see when you Google the unit circle. So you start over here at the positive x-axis at 0 degrees. 0 degrees is the same thing as 0 radians. 30 degrees is pi over 6 radians. 45 is pi over 4 radians. 60 degrees is pi over 3 radians. 90 degrees is pi over 2 radians. 120 degrees is 2 pi over 3 radians. 135 degrees is 3 pi over 4 radians. 150 degrees is 5 pi over 6 radians. Of course, 180 degrees is pi radians. 210 degrees is 7 pi over 6 radians. And you can just count your fractions all along the way if it makes it easier. 5 pi over 4 radians, 4 pi over 3 radians, 3 pi over 2 radians. 300 degrees is 5 pi over 3. Whoops, I'm putting it in the wrong way. 5 pi over 3 radians. 315 degrees is 7 pi over 4 radians. 330 degrees is 11 pi over 6 radians. And of course, 360 is 2 pi. And so we can look at the coordinate values here. We'll start over here in quadrant 1. All right, so 30 degrees in terms of the coordinates would be square root of 3 over 2, 1/2. Square root of 2 over 2, square root of 2 over 2. And then 1/2, square root of 3 over 2. And then, of course, 90 degrees is already labeled at 0, 1. Moving over here to quadrant 2, 120 degrees is negative 1/2, square root of 3 over 2. 135 is going to be negative square root of 2 over 2, and then square root of 2 over 2 positive. And then 150 is going to be negative square root of 3 over 2, and positive 1/2. And 180 degrees is already labeled at negative 1, 0. So moving on to quadrant 3, 210 degrees is going to be the same thing as 30 degrees, but just adjust the signs. So it's going to be negative square root of 3 over 2 and negative 1/2. The 45 reference angle for 225 degrees, both are going to be negative. Coordinates over in quadrant 3. And finally, with a reference angle of 60 degrees, we'll be at negative 1/2, negative square root of 3 over 2. And the 270 degrees is labeled at 0, negative 1. So you get really used to this. You can almost write this out with not even looking at a reference table. You just get really used to seeing these numbers. Just knowing where things are positive and negative in what quadrant. And for 30 degrees, we're at negative square root of 3 over 2. And, sorry, that's positive square root of 3 over 2 and negative 1/2. And finally, all the way around the horn is 1, 0. And then the last thing, the reason why you have these dashed lines out here is just to draw the point home here. I'll actually zoom on each quadrant. So 0 degrees or 360 degrees. We can look at this ordered pair as the cosine of 0, or you could put 360 in there, and the sine of 0 degrees. Up here is the cosine of 30 degrees, comma, sine of 30 degrees. Up here is the cosine of 45 degrees, sine of 45, cosine of 60 degrees, and the sine of 60 degrees. And up here, cosine of 90, and then the sine of 90. And you can keep going around and just write in all of these values for either, you can either put in here, I should say, the cosine of 0, the cosine of 30, or you could say the cosine of pi over 6 if you wanted to use radians. And you could fill that in for every one of these values. All right, so that's an introduction of the unit circle and how to use it to either find values for coordinates or values for the cosine or sine of special angles. or you can use simple little equations and solve back for the angle using inverse operations. Thanks for listening.